So you've got up top, you got to make sure that you know where the A, the C, and the D are. We're not going to really talk about the B value. Okay. Now you do need to know that a lot of equations that you'll get, it may also look like this, especially if it is a vertical stretch. Okay, so, and I'll write the two examples side by side whenever we get to some that with actual numbers in there showing you that they're the same thing. But those two are the exact same thing. Probably the most difficult part of this is getting used to this graph, right? That's the parent function. That's what it looks like. It almost looks like there's two parts of it, which, I mean, technically there is, but whenever we talk about the C and the D value, we're going to talk about things called asymptotes. And so the C value, and I'll explain what that is really whenever I'm going to kind of walk through a homework problem at the end of this. Right here, I want you to put that the C value, it moves the vertical asymptote. Now you spell that as ASYMPTOTE. And then your D value, that is going to move the horizontal asymptote. Okay, so looking at the parent functions, where those would be located on there is currently just on this one. The vertical asymptote is right on top of the y-axis for this. And the definition of that is because technically it's not part of the graph, so you would say it's kind of an imaginary line that these two parts of the graph, they will get closer to and closer to, but they'll never actually touch it. And then you would have the horizontal asymptote, which it's the same idea, but now with this part and this part right here.
Wait, what's
Okay.
the horizontal?
The horizontal would be this line right here.
Okay.
And then your vertical is that one right there. Okay, and we'll talk about those more further into the unit. Okay, so let's go through these rules again, make sure that we're good on those. If it is plus C, which direction does that move the graph? Left. Minus C? Would be right. Plus D? Minus D? If A is greater than 1, it is going to vertically what? Stretch. Between 0 and 1, it is going to vertically compress. And if A is negative, reflect over the what axis? X-axis. So let's look at a few examples. Okay, so Trent, what is the transformation on number 1?
Wait, we've already done this.
So what is that 3/4 doing? Is it the A, the C, or the D? If it's out front?
Oh, it's in front.
Okay, so what is it doing? So it is vertically compressing by 3/4. Holly, number 2. To the right 5. Your C value is always going to be in the denominator. Okay. Catherine, 3. It reflects. Austin, 4.
To the right 4.
Jen, 5.
Vertically stretch.
Malachi, 6.
3.
If it's
Right.
left 3. If it was up, it wouldn't be part of the fraction. Okay.
Number 3, wouldn't there have to be parentheses and then the negative sign outside? Like, why is the negative?
Okay, so let's look at a few that have multiple transformations. So, Kate, what would one of the transformations in number 1 be?
Left three.
Okay. Tanner, what would the other one be?
Down 4.
Rhett, what would one of the transformations in number 2 be? Sophia, what's another one? And Kate Sutterth, what's the last one? Hannah, number 3.
Reflect over x-axis.
Lisa Betta, what's another one?
Up 2.
Austin.
Right 8.
Nick, what's the last one?
Reflects
I already got that one.
vertical stretch of 3.
Okay. Just make sure you're able to dissect the equation and get the transformations out of it. So coming down here, alright, so go through this. If I call on you, tell me what letter I need to replace with what number. So it says that it goes up 4, left 2, vertically stretched by 3, and reflected across the x-axis. So, Trevor, what would be one of the numbers I need to put in there? Brianna helps out. Okay, where at? Okay, and I'm going to go ahead and put it up top, and this is where I'm going to draw the 2 comparisons at the end. Okay, Cole, what's plus 2? And Jen, what needs to be at the very end?
Plus 4.
Okay, so this right here is the same as this. Okay? Because this is telling me to multiply -3 times that fraction. Which if I was to do that, I would get -3 over x plus 2, which is what I had originally. Okay, so it's the same thing. It does not matter which way you write it. If it's a problem like this and you're asked to write the equation, I will tell you though, if it's a vertical stretch, it will most likely look like this. If it's a vertical compression, it'll look like that one up there. Okay. Alright, so same thing here. Chainer, tell me a number that I need to substitute in for.
1.5 foot 8.
Okay. Emma, what's another one?
X plus 8 plus
And Casey.
7.
Awesome. Okay. Questions on any of that?
Is that like all of this?
Yeah.
That's all?
For equations like this that just have a number up top. Okay. So look up here with me real quick. All right, this is the homework, so I kind of want to talk about how to go about graphing it, because we didn't actually graph it on there, and it's not hard at all. Okay, so whenever I've got, what would my two transformations be on this one? Right 2 and up 3. Okay, so whenever we wrote down what the C and the D value do, when the C value moves the vertical asymptote, the D value moves the horizontal asymptote, those two are always going to start where they are on the parent function, okay, which is right there and there. So whenever it says to move right 2, I think it's easier to picture the vertical asymptote moving to the right 2 and your horizontal asymptote moving up 3. Now, the hardest part on this is remembering which side it goes on, if it reflects or if it doesn't reflect. If it does not reflect, it's in the bottom left. Bottom left and top right. So if this equation had a negative in the front, it would still be here and here. That would be the intersection of the asymptotes. The only difference is it would be there and there.
Can I just put this on a y equals calculator?
Yeah, but I want you to be able to identify where those are, okay? Where the asymptotes go. It's just, that's what's the right and the left. As far as how accurate these are, that doesn't bother me. I just want you to know that on this one it would be here and here. And you can just put that on there. We'll talk about how to graph that accurately later on. Okay? But all I need you to know is identify where the asymptotes are, be able to look at the equation and get the transformations for today.
So your just keeps going like that.
That, and then I still want these drawn in the correct, like,
Yeah.
I wouldn't want them here. I want them here.